So for question 20a, they ask us evaluate limit at infinity. So this is our concept at point 1. When we try to substitute our infinity, we get infinity over infinity. So how to simplify this IDF? So when we have IDF involving limit at infinity, we will divide the highest power. But we see our question here, we got cert. So means that we will follow our cert. We will divide the highest power inside the cert. The highest power inside the cert is x squared. So inside the cert here, we will divide by x squared. So when we simplify, it is actually equals to modulus x. So as we know modulus x, it can be expressed as piecewise. When it is positive, greater or equals to 0. When it is negative, less than 0. So our limit, which is approaches x from negative infinity. So for this part, which is a function does not involving cert, we will divide by negative x. So under the cert function, we will pick together with the cert symbol cert, so which is x squared. 2x squared divided by x squared. 3x divided by x squared. So at the denominator part, the function without cert, which is a linear function, we will take the simplified one. The simplified function that we get here is approaches negative infinity divided by negative x. So 5 divided by negative x. 1 divided by negative x. Then we simplify our function. So this is 2, 3 over x, negative 5, negative 1 over x. Then substitute our x equals to infinity. We will notice that 3 over infinity is 0. Then 1 over infinity is 0. So we get a cert 2 over negative 5. So definitely this is our concept, how to simplify our IDF form involving limit at infinity. So simplify our function, try to substitute our limit to get to the answer. So make sure we divide to the things that is accurate. Under the cert, we pick x squared. Outside the cert, we pick the function that we had already simplified, which is negative x, because x approaches negative infinity. So x is less than 0. So the function involving here is negative x. So for question B, they give us a piecewise function. They said find the value p and q. They ask us to find the missing value in the function here, where this function is continuous for all value of x. So we draw out our interval first, where we have negative 2 until negative 1. Our function involving is 5 minus px. When we have 1 until 2, our quadratic function is x squared plus px plus q. Then when we have x greater than 2, it is a rational function, x squared minus 4, x minus 2. So the question here, they say they're definitely continuous for all value of x, means this part, from this part, middle part, and the right hand side part, they definitely can be continuous. So in order to make them continuous, we can do it limit. When x equals to negative 1, we can see x equals to negative 1, left hand side, right hand side, different function. So we want to make sure they are equal. And then another concept is when x equals to 2, when you see that is a changing function, we want to make sure it is continuous. The limit from left hand side must be equal to limit from right hand side. So that is the two concepts we have here. So we start from the limit approaches negative 1 from the left hand side. So this part. So x negative 1, left hand side, function involving 5 minus px. It must be equals to limit approaches negative 1 from the right hand side, which is x squared plus px plus q. So we solve this limit, substitute our negative 1 inside here. we get 5 plus p. We solve this negative one, substitute inside, it will be 1 minus p plus q. So we'll build out a simultaneous equation. So let us simplify this simultaneous equation. Move the p to the left hand side, we get 2p minus q, and then the value we move to the right hand side, minus 4. So equation 1. Then we continue for another part here, which is x equals to 2, another part of changing function. So limit approaches 2 from the left hand side, x squared plus px plus q must be equal to limit approaches 2 from the right hand side, which is x squared minus 4, x minus 2. So can we substitute our value of 2? So this one definitely okay. So this is IDF. 4 minus 4 is 0, 2 minus 2 is 0. So we have to simplify our IDF functions. So for this left hand side, we can attempt our limit. We can find our limit, which is 2 squared is 4 plus 2p plus q. But right hand side, our limit notation still need to carry on because we need to simplify function first. So x squared minus 4 will be x minus 2, x plus 2. Then finally only we can get to the answer. So this 2, 4 plus 2p plus q equals to 2 plus 2, 4. Simplify our simultaneous. It will 2p plus q equals to 0. So we can see our simultaneous equation here. One is negative q, one is positive q. We can do our elimination method by taking operation of equation 1 plus equation 2. So when we plus it together, our p will get 4p, our q will be eliminated. Then this is negative 4 plus 0 equals to negative 4, p is equals to negative 1. So sub into either one equation. I pick number 1. So we managed to find the value of q and value of p. So this is our concept. Make sure limit left hand side equals to right hand side to build out our first simultaneous equation. And then same occur at x equals to 2 and solve our simultaneous equation to get to the answer, which is p equals to negative 1, p equals to 2. We continue for part C. We are going to draw this piecewise function. So actually this is our concept from chapter 5. So using the value pq obtained in part 1. So first of all, we write our function completely. Our function fx so it will be 5 minus px. P is negative 1. So 5 plus x. This is a linear graph. For negative 2 until negative 1, linear graph. Then in the middle piece here is a quadratic graph. So we put in our negative 1 and 2 here. Less than x, less than equals to. Okay, less than x, less than equal to. And then this function we have simplified. Just now we have simplified. It is actually equals to x plus 2 only. The rational function, we simplify it. We already simplified it in the part of finding part 1 here. So it's x plus 2 only for x greater than 2. So we have three graphs to draw here: linear graph, quadratic graph, linear graph. So we have three parts. So we are drawing our piecewise function part by part. So sketch out our x-axis and then our y-axis here. So our graph starting with -2, so we plot it -1, -2, and then 0, 1, 2. So you have to understand from -2 and 1 here. This part, one graph, -1 until 2, one graph, in the middle, 2 onwards, another graph. So for each graph, we have our starting point and ending point. So for x equals to -2, we want to draw this linear graph. So we find out when x equals to -2, our function y equals to 5 plus x, y equals to -2, so 3. So our 1, 2, 3, 4. So our point included. This is our starting point for x plus 5 plus x. Ending point when x equals to -1. Y coordinate equals to 4. So this is my ending point. So in between here is our linear graph, so straight line. Linear graph 5 plus x, linear graph, straight line. So label our coordinate 4, 3, and then y-axis, x-axis. So this is our first piece. We done our first piece. So means that we done this part already, -2 to -1. Then we continue for in the middle part here, -1 until 2. So for the middle part, of course we will draw it in the same interval. Because piecewise function means part by part it has different function, but we will draw it in the same axis. So when x equals to -1, our second part here, starting point, -1 square, then +1, then +2, so it is equals to 4. So they are continuous. They are continuous at the same point. So when x equals to 2, y equals to 2 square minus 2 plus 2, so it is equals to 4 here. It is a quadratic, so it is a quadratic. So we want to make sure when we drawing our quadratic, the smiley graph here, the graph intersect my y-axis. So I have to find out y-intercept. So y-intercept is equals to when x equals to 0. When x equals to 0, y-intercept equals to 2. So what is the axis of symmetry? So we can see our quadratic here using our quadratic when y equals to x squared minus x plus 2. Doing our computing the square, y is equals to x minus 1 over 2 square, then minus 1 over 2 square plus 2. So our axis of symmetry occur at x equals to -1, -1 over 2 here. And its minimum point is at 7 over 4. So we can see after we completing the square, we can see our minimum point, which is 1 over 2, 7 over 4. This is our 1 point something. This is our minimum point. So our smiley graph will intercept at 2, and then symmetrical axis at 1 over 2 and going up back. So this is our quadratic. So after we done our part 3, part part 2, we're going to draw our last part when x equals to 2, our y equals to 2 plus 2, which is 4. So this is my linear graph starting at point x equals to 2, y is 4. So it is positive gradient. So means this graph is increasing. So increasing, how's the increasing? The gradient will be, so you can see this is linear graph, this is linear graph, their gradient, they are same, mx plus c. So 1x plus 5, 1x plus 2. So these two lines, they are having the same gradient. So when they're having the same gradient means they are in parallel. So make sure your gradient, they are same. So this line and this line, they are having the same gradient. So you're going onwards because it's at more than 2. So this graph is going onwards, non-stop. So this is how we draw our part. Piecewise functions. So every time we draw our graph, 3 marks. First part will be our shape. Make sure we have our shape correctly. Here we have quadratic, a linear shape. Then secondly, we have our point correctly because this is piecewise functions. We want to make sure uh, our starting point and ending point for each interval of the graph is correctly and labeled. So lastly, our label it completely. So label your x-axis, label your y-axis, of course label your functions. So our function here, it will be fx. Or you can label it, this is 5 plus x, this is x squared minus x plus 2, this is x plus 2. Make sure your x-axis, y-axis is labeled with the origin.